So before referring this particular video, please make sure that you have referred all the previous videos. Now friends, let's come towards heating effect of electric current. Actually, moving electrons in a conductor lost energy and which can result into heat energy. So let's discuss something about electric circuit. Friends, in the electric circuit, there is a source of energy. Source of energy, just like right here, this is a source of energy. And this source of energy, due to the potential difference, can cause इलेक्ट्रिक करंट फ्लो थ्रू द सर्किट. इस सोर्स, क्योंकि यहाँ पे नेगेटिव पॉजिटिव टर्मिनल की वजह से पोटेंशियल डिफरेंस है एंड दिस डिफरेंस इन पोटेंशियल कैन कॉज द फ्लो ऑफ करंट थ्रू द सर्किट. तो करंट यहाँ पे पूरे सर्किट में फ्लो करेगा. नाउ फ्रेंड्स, द अमाउंट ऑफ एनर्जी दैट कम्स फ्रॉम द सोर्स कैन कन्वर्ट इनटू हीट एनर्जी. So this is known as heating effect of electric current. So potential difference के कारण से करंट फ्लो हुआ और पोटेंशियल डिफरेंस किसी पर्टिकुलर सोर्स ऑफ एनर्जी से अवेलेबल होता है, उससे करंट फ्लो होता है. और करंट का मतलब है मोशन ऑफ फ्री इलेक्ट्रॉन्स. एंड अगर ये फ्री इलेक्ट्रॉन्स मोशन कर रहे हैं तो इट मे बी पॉसिबल ड्यू टू देयर मोशन some amount of energy can convert into heat energy in the conductor. So we can use this heat energy in this manner that we can calculate the amount of heat energy just like according to the respected formula. Friends, we know that Q equals to IT. Current equals to charge per unit time. And when an electric charge Q moves against a potential difference V, we can define the amount of work done in this manner. I can have work done equals to charge multiplied by potential. This is our next formula. So I can write this equation first. Now friends, further, from the Ohm's law, as we have discussed, from the Ohm's law, I have V equals to IR. V equals to IR. If this is our equation A, if this is our equation 1 and this is our equation 2. So by using these three equations and by plugging the value of equation A and equation 2 into the equation 1, I may have W equals to, at the place of Q I am going to write IT and at the place of V I am going to write IR. So friends, in this manner हमें एक फॉर्मूला यहाँ पे डिड्यूस होता हुआ दिख रहा है. W equals to I square RT. So friend, if this is the amount of work done in the circuit, then अगर यहाँ पे हमें देखें कि this work is called electrical work, and in the electrical circuit, if this is purely resistive circuit, that is the conductor has resistance only, then connected to the battery, so all the electrical energy consumed is converted into heat energy. So if all the electrical energy is just converted into heat energy, then I can write H equals to W equals to I square RT. Or directly I can write, I am going to remind it, just make it sure that work is equals to energy according to the work energy theorem. So I am using this particular concept here. Or I can write H equals to I square RT. So friend, this is our Joule's law of heating. So we can utilize the particular heat which is just actually developed into the circuit in this manner. So it is because Joule was the first scientist who studied the heating effect of electric current through a resistor. So according to the Joule's law of heating, we will have this particular relation H equals to I square RT right here. H equals to I square RT, just like right here. we may conclude that the amount of heat produced in a conductor is directly proportional to number 1, square of the current through the conductor for a given resistance and time. Number first is square of the current. Number 2, resistance R of the conductor. And number 3, time for which the current is passed through the given conductor. So we may have H is directly proportional to the square of the current, resistance and time. So we will use this particular relation in order to solve lots of problems in our syllabus. If I talk about first conclusion, heat produced in a conductor is directly proportional to the square of the current, means H equals to I square. So friends, we can use this particular relation. Number 1, अगर हम बात करें कुछ पर्टिकुलर इस प्रकार के रिलेशन में जिसमें करंट की वैल्यू डबल कर दी गई, तो लेट्स से रेशो H डैश ओवर H equals to H dash over H equals to 2I over I. So in this manner 2I over I with the square, because heat is directly proportional to the square. So I can have 4 here. So friends, if the current is doubled, this is final value and this is initial value, and final heat के लिए final current की value ये, and final initial heat के लिए initial current की value this one. So if current is doubled, then new current become 2I. New current become 2I, and so if we double the current, then heat will produce become 4 times. हमने यहाँ देखा फाइनल और इनिशियल हीट, अगर फाइनल और इनिशियल हीट को अगर हम डिवाइड करें तो रेशो विल बी 4. तो इससे पता चलता है कि अगर करंट डबल हो जाएगा तो हीट विल बिकम 4 टाइम्स. एंड इसी प्रकार से वी कैन हैव अनदर रिलेशन. अगर हमने करंट को हाफ कर दिया, देन व्हाट विल बी द इफेक्ट ऑन हीट? इफ आई हाफ द करंट, देन if current is half, then new current will become, if initial current is I, then new current will become I by 2, just like, so I may write half of I upon I with the square. So I may have in this particular relation 1 by 4. So if current is half, then new current become I by 2 for a given resistance and time. So if the current is half, then the generated heat will become 1/4. So friend, in this manner we can apply lots of relations. So let's talk about another conclusion. Heat produced in a conductor is directly proportional to the resistance. So if resistance is doubled, then new resistance will become 2R for a given current and time. So I may have, if I double the resistance, then new current will become, new heat and new resistance will have this particular relation. So friends, this one is one first heat HF, or I can say H final. This is initial case, this is final, this is initial case. So initially if resistance is R, then its heat is H, and finally if resistance is RF, and RF is equals to RI, just like right here I remind this is RI, I may write this RI. तो final resistance is 2RI, means हमने इनिशियल रेजिस्टेंस की वैल्यू को डबल कर दिया फाइनल में, तो फाइनल हीट विल बिकम दिस. सो इन दिस मैनर वी कैन कंक्लूड दैट H final equals to 2HI. So in this manner, if resistance is doubled, then heat produced will also get doubled. Or another, this is our first conclusion, and we can make another example, just like if this is final heat, this is initial heat, and I divide final resistance to the initial resistance, then I may have half. So इसका मतलब अगर इनिशियली रेजिस्टेंस R था और फाइनली हमने रेजिस्टेंस की वैल्यू हाफ कर दी, तो इस प्रकार से हम ये देख सकते हैं कि जो यहाँ पे फाइनल हीट आएगा वो भी हाफ हो जाएगा इनिशियल हीट के. So in this manner, if the resistance is halved, the new resistance will become R by 2 for a given current in time. And so if the resistance is halved, then heat produced will also get halved. And in the same manner, heat produced in a conductor is directly proportional to the time. So we can relate this from this particular relation, H dash over H equals to 2T over T, and H dash is another heat, this is another heat. So initially T टाइम पे H हीट थी, 2T टाइम पे H dash हीट हो गई. तो इसका मतलब हम ये कह सकते हैं कि if time for a current to pass in the conductor is doubled, then heat also get doubled in this manner, or I can write in this particular manner, H dash equals to 2H right here. In the similar manner, we can make half. So if the current is passed through a conductor for half the time, then new heat will become half.